Hello and welcome to this series of learning we are calling modern operating systems. And as I told you, it's a book by Tanenbaum and Herbert both. And we're going to be reading it together to get an understanding of modern operating systems. And so if you're here last time, you know we went through the table of contents and we started with the introduction section. We did the processes and thread section. We did the memory management section. Now we're going into the other section of the contents, and this is the file system. So this is section 4. So under that, we're going to learn about file naming. We're going to learn about file structure. We're going to learn about file types. We're going to learn about file access. We are going to learn about file attributes. We're going to learn about file operations. We're going to look at an example program using file system calls. And then we're going to look at directories. And we're looking at a single level directory system. We're going to look at hierarchical directory systems. We're going to look at path names, and then we're going to look at directory operations. And then we're going to look at file system implementations. And here we look at file system layouts. We look at implementing files. We look at implementing directories. We look at shared files. We'll look at log structured file systems. We'll look at journaling file systems, and we shall look at virtual file systems. Then we look at file system management and optimization. And here we look at disk space management. We look at file system backups. We look at file system consistency. We look at file system performance. And then we look at defragmenting disks. And then we look at example file systems. We look at the MS-DOS file system. We look at the Unix version 7 file system. We look at the CD-ROM file system. This one is obsolete, but we just look at it for the sake of learning. And then we'll look at research on file system. And then we'll look at a summary. And then we're going to look at inputs and outputs in section 5. And here we look at principles of input and output hardware. We look at input and output devices. We look at device controllers. We look at memory mapped input and output. We look at direct memory access. And then we look at interrupt revisited. This is what direct memory access is what we sometimes call plug and play, something like that. But yeah, we look at that. And then we look at principles of input and output software. We looked at the goals of input and output software. We looked at programmed input and output. We looked at interrupt-driven input and output. We look at input and output using DMA. Then we look at software layers. We look at the interrupt handlers. We look at device drivers. We look at the device-independent input and output software. And we look at use space input and output software. Then we look at disks. We look at disk hardware. We look at disk formatting. We look at disk arm scheduling algorithm. This is for what we call the hard disk drives, but mostly today we have moved to solid state drive. But it's important to just understand the mechanics because like in Africa, most of the systems are still using the hard disk system. Then we look at error handling, and we look at stable storage. Then we look at clocks. And then we look at clock hardware, we look at clock software, and then we look at soft timers. Then we look at user interfaces, so the keyboard, the mouse, and the monitor. And we look at the input software and the output software. Then we look at thin client. Then we look at power management. Here we look at hardware issues. And then we look at operating system issues. We look at application program issues. Then we look at research on input and output, and then we'll do a summary on that. Then we'll go into deadlocks, and then we'll look at resources. We look at preemptible and non-preemptible resources. We'll look at resource acquisition. Then we look at introduction to deadlocks, not dreadlocks, but deadlocks. And then we look at conditions for resource deadlocks. And then we look at deadlock modeling. Then we look at the ostrich algorithm. Then we look at deadlock detection and recovery. So we look at deadlock detection with one resource of each type, and then we look at deadlock detection with multiple resources of each type. Then we'll look at recovery from deadlocks. Then we'll look at deadlock avoidance. So we look at resource trajectories, we look at safe and unsafe states, we look at Banker's algorithm for single resources, and then we look at Banker's algorithm for multiple resources. Then we look at deadlock prevention, and then here we look at attacking the mutual exclusion condition. Then we look at attacking the hold and wait condition. We look at attacking the no preemption condition, and then we look at attacking the circular wait condition. Then here we look at other issues. This includes the two-phase locking. We look at communication deadlocks. We look at live lock, and we look at starvation. Then we look at the research on deadlocks and then a summary. Then we go into section 7 where we look at virtualization and the cloud. We look at the history, we look at requirements for virtualization, we look type 1 and type 2 hypervisors, we look at techniques for efficient virtualization. So virtualization with the here we look at virtualizing the unvirtualizable, and then we look at the cost of virtualization. So we'll also look at our hypervisors, microkernels done right. Then we look at memory virtualization. We look at input and output virtualization. We look at virtual appliances. We look at virtual machines, multi-core CPUs, and then we look at licensing issues. We look at clouds. We look at cloud as a service. We look at virtual machines migration, and we look at checkpointing. Then we'll do a case study about the VMware, and then the early history of VMware. We look at VMware Workstation. We look at challenges in bringing virtualization to the x86, that is after 1986. We look at VMware Workstation solution overview. We look at evolution of VMware Workstation, and then we look at ESX servers, the VMware type 1 hypervisor. Then we look at research on virtualization and the cloud. Then we look at multiple processor systems. Then here we look at multiprocessors. So multiprocessors hardware, we look at multiprocessor operating system types. We should look at multiprocessor synchronization and multiprocessor scheduling. We look at multi-computers. So here we look at multi-computer hardware. We look at low-level communication software. We look at user-level communication software. We look at remote procedure calls. We look at distributed shared memory. We look at multi-computer scheduling, and we look at load balancing. Then we look at distributed systems. Here we look at network hardware, we look at network service and protocols, we look at document-based middleware, we look at file system-based middleware, we look at object-based middleware, and we look at coordination-based middleware. Then we shall look at the research on multiple processor systems, and then a summary. Okay. Once again, we'll stop there for this section. We have one more section left for content, for the table of content. So be patient because we need to go process by process, so we keep on understanding what you're looking at. Okay. So in the next section, we shall cover the rest of the table of content that we are left with. Okay. So be patient. We'll be coming with that. Then we shall now get into the reading of the book. Thank you for joining, and looking forward to see you on the next one.